Welcome to Star Chat, the podcast where we explore the wonders of the universe and bring you the latest news from space. I'm your host, Carl, and I'm excited to share with you a fascinating story about a new NASA mission that's helping scientists better understand exoplanets. Imagine being able to detect water on a planet orbiting a distant star, or determining if an exoplanet has an atmosphere similar to Earth's. These are the kinds of questions that astronomers are trying to answer as they search for life beyond our solar system. But one of the challenges they face is something called stellar contamination, where the light from the host star can mask or mimic features like water in the planet's atmosphere. That's where NASA's new mission, Pandora, comes in. Launched on a budget of just $20 million, Pandora is a small satellite that's designed to help scientists correct for stellar contamination and get a more precise reading of exoplanet atmospheres. The mission is focused on observing 20 exoplanets, including some that orbit small dwarf stars, which are considered to be prime targets in the search for life. The Pandora spacecraft is equipped with a 17-inch telescope, courtesy of Lawrence Livermore National Laboratory, and uses a small satellite platform from Blue Canyon Technologies. By taking advantage of advances in small satellite technology and shared launch opportunities with SpaceX, NASA was able to keep costs down and get the mission off the ground quickly. As Dr. Stephen Clark, a space reporter, noted, "There is no way we could have done Pandora 10 years ago." The small launch capabilities that come from companies like Rocket Lab and SpaceX and others meant that now the vendors of spacecraft buses and spacecraft instruments are able to push their costs down because they know that there's a market for small missions out there. With Pandora, scientists hope to gain a better understanding of exoplanet atmospheres and take a big step closer to answering the question of whether we're alone in the universe. And who knows, maybe one day we'll find evidence of life on another planet. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. We're exploring the latest developments in space technology and exploration. Today, we're diving into a fascinating story about NASA's efforts to identify and address critical technology shortfalls in the civil space sector. NASA has recently released a list of 32 technology shortfalls, and they're inviting the public to provide input on these critical needs. This feedback mechanism is designed to inform national space technology priorities and guide the Space Technology Mission Directorate's evaluation of current development efforts. We're also hearing from Richard, a NASA engineer, who shares his insights on the importance of persistence and attitude in pursuing a career in space exploration. He recommends that students do their research, figure out what they don't know, and find someone who can help fill the gap. In related news, NASA's Space Technology Mission Directorate is seeking public input on its 2026 Civil Space Shortfall Ranking. The feedback period is open until February 20th, and participants can register to provide their thoughts on the most critical technology needs. As we continue to push the boundaries of space exploration, it's essential to address these technology shortfalls and invest in innovative solutions. By working together, we can drive progress and achieve great things in space. Welcome back to Star Chat. As we conclude our journey through the cosmos today, I'd like to take you to a fascinating discovery that has left astronomers perplexed. Imagine a star that's died, yet still manages to create powerful shockwaves in space. This phenomenon is exactly what scientists have observed coming from a white dwarf star about 730 light-years away from Earth. This particular star, known as RxJ0528+2A38, is part of a binary system, accompanied by another star similar in size to our Sun. What's intriguing here is that the dead star doesn't have a disk of debris around it, which is typically how such stars interact with their companions and influence their surroundings. However, observations using the European Southern Observatory's Very Large Telescope revealed something unexpected: a bow-shaped shockwave, or bow shock, emanating from this seemingly inactive core. This finding challenges our current understanding because the conventional wisdom suggests that, without a disk to facilitate the transfer of material from its companion star, a white dwarf shouldn't be able to produce such an outflow. The team behind this discovery believes that the key to this enigma might lie in the white dwarf's strong magnetic field, which could potentially allow it to gather material from its companion. This magnetic field acts somewhat like a mystery engine, driving processes that we're still working to fully comprehend. One of the most captivating aspects of this find is the duration over which this phenomenon has occurred. The outflow has been observed to have persisted for at least 1,000 years, raising questions about how such a long-lived process could be sustained without the typical accretion disk. As we delve deeper into the mysteries of the universe, discoveries like these remind us of how much there is still to learn and explore. The study of white dwarf stars and their interactions with their environments not only expands our knowledge of stellar evolution, but also invites us to ponder the vast array of phenomena that await us in the cosmos. That's all for today's Star Chat. Remember to like, share, and subscribe, and until next time, remember to keep looking up at the stars.